Okay, so on the back side of today's notes, where we're talking about functions, notice what it says. A function is a type of relation. So it has its own standards. In other words, not every relation can be a function. Not every relation can be a function. You can all be boys, but you can't all necessarily be basketball players. You just don't have the skills. You can all be girls, but that doesn't mean you can all be in speech because you don't have the skills, or maybe even the desire, right? So when we talk about a function, it's a special type of relation, and it has some standards it meets. It's a type of relation where each x value, and remember the x values come from the domain, like it says here. It says the x values come from the domain, can be paired with only one y value in the range. And that's really important, that order. Right now you need to, so we have to get it in our head that I want you to circle the word function so you don't have so many words to try and remember. Function, each x value, we're underlining now, can be paired with only one y value. Those are the important words in there right now. Those are the things I want you to get up here and say, okay, when she asks me if it's a function or not, or the question asks me if it's a function or not, that's what I have to think about. Can each x value be paired with only one y value? And this is tricky. As easy as that sounds, your brain wants to try and reverse that sometimes, okay? So there are some examples here at the top of our page. We have it in table form. Remember, we have different ways we can write relations. And remember, or maybe I should say remember, a function is a relation. Remember I said it's a special type of relation. So a function is a relation. So it's a set of ordered pairs. And each x value can only be paired with one y value. So in this one, 2 is paired with 3. 3 is paired with 4. 4 is paired with 4. 5 is paired with 6. And they're saying that that one is a function. Anybody want to disagree? Or can you say why it would be a function? Right?
Are they functions because what's on the y table is larger than what's on the x?
Okay, so the value of y is larger than x? No, it doesn't say anything about their relationship as far as size goes. So, Cameron.
There's 2 4s in the y.
There's 2 4s in the y, so you're thinking what then?
It's not.
Can't be a function then, maybe. Okay. Isaac, were you thinking the same thing?
Nope.
No? Okay, what were you thinking, Isaac?
I was thinking what's a function? It was on each, the x's were on the y's, all each ones.
Okay, so each x has only one y. So this x equals 2, has a y value of 3. Are there any other x equals 2 in that table? Are there any other 2's in that table for x?
No.
Okay, so then that's the only y value for that 2, is it not? Okay, how about that 3? That 3 is paired up with that 4. Is there any other x equals 3 in that table? Are there any other 3's for x?
No.
No. So then x equals 3 only has one pairing, it's 4. And then we move over and we say, okay, well when x is equal to 4, it's paired up with 4. Are there any other x's in that table that are 4? X's that are 4? No. So when x is 4, it only is paired up with the y value 4. See what our definition says. Each x value can be paired with only one y value. Does it matter what that y value is? Does it matter that it's a y value that another x had? No, it matters that it only has one of them. And same thing here with 5. We only have 1 5 in that table, and it's paired up with 6, so it only has one y value. So in a table, that's how you would look. You'd say, okay, first of all, are there any x's repeated?
No.
And if there are any x's repeated, then you'd say to yourself, well, are those x's paired up with the same y values then? Because if they're paired with different y values, you'd say, that's a problem for a function. It can't be a function then. Look at what happens on a graph. When we have them as ordered pairs on a graph, here's what we look for. We can run what's called the vertical line test. Or in other words, remember what we said about a vertical line? We had one on our homework for today. We said all the x values were the same for all of those points, right? Okay. Or were the y values the same? Which one is it? What's the same for all the points on the vertical section? Are all the x values the same? Just changing the y's going up and down? Well, here's what we're going to do. If we run a vertical line through it and there's only one point on that vertical line, is there a problem? Could there be a different y value for that x? No, there really can't be. But if there was another point up here, let's just make another point up here. What if there was another point up there? Now we would say when x is equal to 2, we have y equal to 3 and y equal to 6. That's a problem, isn't it? When x equals 3, it would have 2 different y values. Or when x equals 2, it would have 2 different y values, 3 and 6. So let me erase all of that and show you. There's only one point that has an x value of 2. And maybe this is what you could do too. You could say, okay, well that's ordered pair 2, 3. And this one, what's that one? What's the next point's name?
3, 4.
3, 4. And what's the next point's name?
4,
4, 4. Oh, this is starting to look like they graphed that table, isn't it? And this is ordered pair
6, 6.
5, 6, I think. Yeah, they graphed that table, didn't they? So they're showing you, like we already said, it is a function because each x value only has one y value. And what happens is you won't have any points lined up above or below each other. So that's kind of what we call the vertical line test. And then I want you to look at this one right here. That's a mapping diagram, right? When x is equal to 2 and x is equal to 7, they have that y value of 4. Is that a problem, Malcolm?
You want us to put those numbers up there?
On the graph, sure, you could do that. That'd be a good idea to plot them on there. All the practice you get naming ordered pairs is always good. In fact, I think we should do that with that mapping diagram. How many ordered pairs are there in that mapping diagram? 4. Yeah. What's one of them?
2, 3.
Mapping diagram.
2.
2, 4. And what's another one, Trey? Or did you have a question?
I was going to say.
Pardon?
I was going to say one.
Okay, say what? That works too.
7, 4.
7, 4. What's another one, Rose? 8, 6. What's another one, Isaac?
2, 4.
We already have that at the top. There's one left. Good, Riley?
15, 12.
15, 12. So remember, these are our x's, these are our y's. The x's are mapped to their y's. Is there any x's used more than once? X's, this is where you're going to look, people. Are there any x's used more than once? No. So can they have more than one y value if they're not used more than once? Probably not. Each x value has only one y value. Okay. And over here now they're showing us some where they're not functions. And they tell us in the top one, 6 is paired with 2 and 3. So we have these two ordered pairs, 6, 2, 6, 3. That x value of 6 has 2 different y values. You can only have one. Look at what happens in the diagram. When we have 2 points that one is above and one is below the other, what's the ordered pair name for those 2 that I've circled? 3, what's the bottom one? 3,
4,
4. And what's the top one?
3, 6.
3, 6. So looky there. 3 is paired with both 4 and 6. It can only be paired with one y value. So it's not a function. Still a relation, but it's not a function. And down here, the problem is when we have x equal to -6, we have a y value of 7. That's that one right there. And when we have x equal to -6, we have a y value of 10. Two different y values for the same x value. Okay, let's try some on our own without them giving us any help. So number 7, we're kind of finishing up from the front side here. Tell whether the relation is a function and explain. Okay, what do you think? That table of ordered pairs, do you think we have a function there or a not a function? That's how we'll say it. Function, not a function. What do you think, Isaac?
Not a function.
You're going to say not a function. How many do you want to agree with Isaac that this one is not a function? Okay, well, what's our reasoning then? We got to explain why.
Oh, it's because the -3 is used twice in the x.
Okay, and what's got to be true though? It can be used twice, but what can be what has to be true? It can't have more than one y value. It has 2 different y values. So let's circle that in our table right there. Not a function when x equals -3. How many different y values do we have? 2 different, well, when x equals -3 equals, I'm sorry, no wonder why you couldn't understand what that was. X equals -3. When x equals -3, there are 2 different y values. So that's our explanation. It's not a function, because when we have the x value of -3, there are 2 different y values. Now, if both of those y values had been 2, or both of those y values had been 3, then we would have said, oh, that's not a problem, because they would have both had only one y value, the same y value. So, points can be repeated. This just isn't a point being repeated. It's a different point. Questions on that? Great.
So, like if the x has 2 the same in values like -3, needed twice, and y for underneath the -3, if they both had the same underpoint, then what would it be?
Then it would be then it would still be a function, because that x value of -3 would still only have one y value. It wouldn't have 2 different ones. It would have the same one. So you're saying if we would change this one, let's say to a 2. We change that to a 2. Now when x is equal to -3, does it have 2 different y values? No, it has the same y value. So then it would qualify as a function now. Okay? But that isn't what it was, so we had to say it's not a function. Okay, let's try the next one, number 8. And I suggest that maybe here's what you do for these, especially mapping diagram ones, because you don't see the ordered pairs maybe quite as easily. List the ordered pairs that are shown in that mapping diagram. So what's our first ordered pair in this mapping diagram?
4 and 5.
Oh, I have a
Okay, question?
When we're writing them out, don't we have to use that bracket thing?
No, we're not doing domain and range right now. We use the brackets for domain and range. Okay? And when we write ordered pairs, we use parentheses, right? So, Trey, give me some ordered pairs from this mapping diagram.
4, 5,
4, 5. Give me another one.
8, 5.
8, 5. Give me another one, someone.
12 and 10.
Okay, I didn't ask you to raise your hands, okay. And last but not least, class, the last one is
16, 15.
16, 15. Okay. How you feeling about this one? Is it a function?
Yes.
Yes.
Okay. Why?
Because
No. Why?
Because that x has its own y.
Each x value has only
One y.
one y value. When x is 4, it only has one y value. When x is 8, it only has one y value. When x is 12, it only has one y value. When x is 16, it only has one y value. So we are going to say it is a function because, there's our explanation, each x has only, and this is important, one y. I suppose we should be using the words value in here. Each x value has only one y value. That sounds a little bit better. Each x value has only one y value, therefore this relation is a function. You actually don't have any homework, but we are going to add to our homework in class here, and we're going to do it together.
No, like when you start.
Yeah, when you start, like tomorrow, you will. Okay, number 9. How are you feeling about that one? Any guesses?
No.
Anybody think it's a function? Anybody want to just like vote for function right now?
Vote for
Okay, I'm
function.
going for function. Okay, we got some takers for function. Okay. How about you? That means the rest of you are saying not a function? Okay. I wonder how we're going to figure it out. How are we going to decide? Well, you know what? Do you remember what I said about some points being above and below each other? Do we have any points in this drawing that we can say they are above and below each other? Anybody see anything? Trey?
the top is.
The top of what? What is this figure?
The top of the triangle.
The top of the triangle, okay.
And the points.
And then straight down below it, there's another one right here. Let's get those ordered pair names.
Negative 1 and 3.
No, ordered pair, this one right here. 3, 3, right?
Mrs. Ryan,
Yeah?
does right below actually work as like a point?
It's gotta be on the triangle sides.
Well then, can't we add like 5 more points to that then?
Oh, there's all kinds of places we can find 2 points above and below each other. I'll show you in a sec here. What's this one's name? The bottom one, that I
have 1, 3.
remember we do the x
3
first.
negative.
3,
Oh,
negative 1, right? Okay. So what do you think?
So not a function.
Not a function, because why?
3.
When x is equal to 3, there are 2 different y values, aren't there? So we found one that all it takes is 1. It only takes 1. When x equals 3, there are 2 different y values, and we've identified them right there on our graph. Now, in reality, there's some other x's that have 2 different y values. And they would be all the other x's in the domain of this, except 1 and 5. Anywhere between here and here, you guys, anywhere between there and there, not including 1 and 5, anywhere between 1 and 5, if you go straight up, there's another point on the triangle. Anywhere, it doesn't matter where you go. There's another point on the triangle. So there's all kinds of places this one breaks down, but you only have to identify one spot. Okay? Questions? Okay, let's open your books to page 173. Let's take that assignment number 87 back in front of you. With a pencil. We're supposed to be working the notes with a pencil. We should be able to keep that in our hand.